Hello, welcome to today's lecture. Okay, this is Math 10 class. We're going to start our very first lecture for this course. We are on chapter 1, Introduction to Statistics. We're going to talk about statistics, what is statistics, and going over some definitions. We are on 1.1. The PDF file is available on Canvas. 1.1, page 1. So, what is statistics? When you hear about statistics, you might think, okay, it's just about numbers. It's about collection of data. In reality, statistics is a branch of math. It includes some steps. Statistics is a branch of math with the following steps. What is the very first step in statistics? Well, as a statistician, the very first thing you have to think about is asking a question. What is the question? So first, in the very first step, we start by asking a question. Ask a question. You might be interested in, for example, finding the average SAT scores in all California colleges. You might be interested in finding the mean or median or mode of housing prices in San Jose. So you start by asking a question. 2, after you ask the question, you need to think about a population to target. For example, when you want to know about the average salary of computer science majors, you need to find a population so you can assign enough resources, enough people to collect the data. Collecting the data. So after collecting the data, you're trying to visualize your data. You're trying to find patterns in your collection. So try to visualize the data. Okay, after visualizing the data, you're interested in assigning a numerical characteristic. What is the mean? What's the exact value? What is the range? What is the standard deviation to that collection? So you try to analyze the data. Okay. So this is about the sample or the population of the targets. Eventually, as a statistician, you're interested in making conclusions about other collections or other populations. Make conclusions or making inferences. That's how we define statistics. So if somebody asks you, what is statistics? You say, hey, it's a branch of math. It includes asking a question, collecting the data, visualizing the data, analyzing them, and finally making conclusions about data. Okay, so we're talking about data. What is data? Definition. Data. So officially we can say that data consists of information, numbers, maybe digits, by collecting the data through observation and so on. So information or data. Data consists of information by observation, counting, measurements, and so on. So it can be numbers, it can be objects. That's why we have two different types of data. Either we can assign a number to them, or we can assign a category to them. We're going to talk about them later. So this is the official definition of data. As you can see, data includes observations, counting, measurements, and so on. When it comes to statistics, we're dealing with two types of collections. Either you're working with a big collection, which is population, or we don't have enough money, we don't have enough resources, we don't have enough time to ask everyone in the population. So what do we do instead? We take random samples from that population and we just study those little samples. Then we make conclusions about the bigger set or population. Definition of population and sample. So population is the collection of all, every. So these are the key words that you need to know. Every. Responses, outcomes. Responses, outcomes, measurements. So think about census. How long did it take for census to collect data from everyone in the United States? They are still keep sending reminders. Hey, please do your census, please do your census. As you can see, it takes a long time. It requires a lot of resources, money, energy. So our preference is population, but in reality, it barely happens to collect data from everyone or all the measurements. So what do we do instead? We take random samples. Definition of sample. So a sample is a sub-collection, a portion. Sub-collection or portion of the population. So they usually use Venn diagram to visualize population and sample. If this is the population, then small proportion of it is sample. this example. The population of all De Anza College students, and the sample is students sitting in Math 10 class. So all Foothill De Anza students is your population, and students sitting in this Math 10 class is the sample. Math 10 students. So let me write it here. Very small sample. On page 1, we have an example. This example says identifying data sets. Let us read this. In a recent survey, so we had a survey, we asked question. 614 small business owners in the United States. Guys, be careful, read it carefully. In a survey, 614 small business owners in all United States. They're asked whether they thought their company's Facebook presence was valuable or not. Out of 614 of them, 258 respondents said yes. Identify the population and the sample. In this example, here you have all small business owners in the United States. So remember the keyword for your population. Then you see keyword all, every, it means that you are working with your population. So what is population? What is the sample? The population is all small business owners in the United States. Is all small business owners in the US. What is sample? Sample is 614 small business owners that were surveyed. This is your sample. 614 of them. Population, we don't have any number that we can associate to the population. What's given? The sample, which includes 614 of all of those small business owners. Some of them responded, some of them didn't respond. So 258 of them responded yes. The rest, we don't have any information. They might respond, they said no, we don't know. We don't have the rest of the information, but this is your sample.
A census gets data from a.
Okay, let us go through a checkpoint. The U.S. Department of Energy conducts weekly surveys of approximately 800 gasoline stations to determine the average price per gallon of regular gasoline. On December 10, 2012, the average price was $3.35 per gallon. Identify the population and the sample and describe the sample data set. So in our checkpoint, you can say that since we have surveys, it means that we have samples, not population. So our sample, so this is your population, all in the US, 800 of the gas stations. A portion of all of them in the United States. This is your sample. So as we mentioned, the data in the sample consists of average price. Very well. So we are moving on to page 2. We're going to define a parameter and a statistics. So far we learned about population and a sample. Population is a very big collection of outcomes. We include everyone, every measurement, every outcome in the population. A sample is a small proportion of population. So statisticians, when they're talking about population, they refer to numerical characteristic of a population as a parameter. And when they're talking about samples, numerical characteristics, they refer to them as the statistic. So definition of a parameter. Numerical characteristics, numerical values, characteristics assigned to a population are called parameters of that population. So when we are talking about smaller portion of that population or a sample, we don't call them parameters. We call them statistics. So numerical description. Numerical description of sample descriptions. Let's add more of sample are called statistics. So what is your job as a statistician? Your job is to identify your population or your sample, then say, hey, I'm talking about parameters or I'm talking about statistics.